Today we will be working on quasi-linear utility functions. This one's pretty interesting, a lot of fun, so let's get started. So here's what our utility function looks like. This part of the utility function is the linear part, and this part is like the logarithm function. So that's why it's called quasi-linear, because it's like half linear, half curved. And so same thing, we have here our income and our prices for each good, right? Whenever I see that, I directly write my budget constraint. Here it is. And so the thing here, to find the MRS here, you, again, same thing, you do the MUX over MUY. But the MUX here, if you go back to your, I don't know, trig class, the derivative, okay, not trig, but the derivative of derivative of natural log is, so if it's just natural log, it's 1 over x. And so whatever constant in front of that just goes on top. So it'd just be 2 over x. Just remember that. Try to go back in your notes and remember that. So the log of, or the derivative of 2 ln x is just 2 over x, okay? And so natural log of, so basically the derivative is whatever, 1 over whatever is inside of this. So that's basically it. And the MUY, again, it's a constant, right? The derivative of a linear function is just this constant, is 3. MRS, same thing, we just do 2 over x divided by 3. A lot of people kind of confuse the denominator, numerator stuff. That x just goes down, right? And you get 2 over 3x. One thing that is very important to notice is one of these variables, when you're taking the MRS, will disappear, okay? It will disappear. Why? Because this is a linear function, right? Because this is a linear function, the derivative of any linear function is just going to be that constant, right? So just remember that, okay, here our variable that disappeared is y, okay? So whenever x, okay, so whatever, this is our budget constraint, right? This is our price ratio, 2 over 3, right? Because it's the coefficient, and our MRS is 2 over 3x. Do the cross multiplication, and you will see that x, our x bundle, or optimal x, is just 1. Now, same thing, right? We're constrained by our income, so we will plug that 1 back into our budget constraint from here, and you would get 2 plus 3y is equal to 14, 3y is equal to 12, and then y is equal to 4, right? That is our optimal condition. Now to move on to the next problem, this one's a bit trickier, near part C, so we'll go through that. Same thing here, right? We have our Q1, we have our Q2. Here we see that the linear function is Q1, so I'm thinking, oh, the Q1 is going to disappear. That's great. So our MRS here is, again, that 1, right? That Q1 is just gone now. Great, because it's a linear function. Divided by, here we have our 4 over the whatever is inside, so it's going to be 4 over Q2, right? One thing to remember, when you're doing 1 over any numerator, denominator, that thing just flips, right? Now we're going to have Q2 over 4. That's our MRS. Our optimal bundle here is, right, MRS is equal to price ratio all the time. So I bring that Q2 over 4 is equal to our 1. Where did I get that 1 from? It's because our P1 is given as 10, P2 is given as 10, so it would just be 10 over 10, right? And that's our 1. Do that cross multiplication and you get Q2 is equal to 4, right? When I get that 4, I plug this back into my budget constraint, right? And I get 10Q1 is equal to 40, or sorry, 10Q1, yeah, plus 40 is equal to 80. That's equal to 40, and then Q1 is equal to 4. Our optimal bundle here is 4, 4, right? We would consume 4 of Q1 and 4 of Q2. So for part C, this is a tricky one, and I'm pretty sure it'll probably pop up on your exam. Here it says Bob's income falls to $10, right? So first his income was $80, now it drops to 10. What will happen to the optimal bundle? Well, we know for sure that the optimal bundle will change, right? But again, like I said before, one thing to remember is that whenever you're taking the MRS, that one variable that is left is the one that you want to keep consuming within the correct bounds, okay? Might not make sense when I'm saying it now, but take a look at this, right? We have our MRS. That MRS does not change. We equate it to 1, right? Because that's the MRS equals price ratio. But we know that Q2 cannot be 4, because if Q2 was 4, then we already have a 40 here. Wait, 40 is way more than $10. Like, I don't have $40. I only have $10 in my pocket, right? So I know for sure I cannot be buying 4 of Q2. But make sure that you know that I'll still continue to buy Q2, right? And I'm just going to kind of ignore Q1. Why am I ignoring Q1? Because it was not even a part of my MRS. It's not even something that I wanted to start off with. Q2 is something that I wanted to keep to start off with, right? So whatever just stays here is the one that you want to keep consuming within the bounds. That's what that means. So here I'm just kind of ignoring this Q1 quantity because I only have $10, right? And my price ratio, my price for Q2 is also 10, right? So I can only purchase 1 of Q2. If I want to purchase more of Q1, I'm going to go beyond my income. I don't even have that much money, right? So I'll automatically just say I'm going to be able to only purchase Q2 once. I can only purchase 1 of Q2 and none of Q1, right? And to check your work, you'll see that, okay, I'll buy none of Q1 and 1 of Q2, and I get 10, and I get that $10, right? I get that income of 10. And so that's why just make sure whenever you get rid of one of the variables, just make sure that, hey, I wouldn't prefer to buy that over the one that is still existing. So yeah, thank you.